All right, so we're going to do your assessment assignment practice. So this is the practice problem that goes with that common assessment that you will complete this week after this video. So the top of your assignment, actual assessment assignment looks the same as this. Make sure you do choose your degree type. So you've got the AA Associate of Arts, you've got the AS Associate of Science, and then you've got the AAT Associate of Arts in Teaching. So if you're unsure, you can leave it blank, but do try to figure out which degree that you do have here. All right. So for this problem, else we don't need the top's not important to you. Excuse me. So it says a sample of argon gas has a volume of 5.4 liters at a temp of 289 Kelvin. When the temperature of the gas is increased to 314 Kelvin, the volume of that should be gas, yes, increases to 5.9 liters. And then we're asked several questions here. So first thing it says is to identify the independent and dependent variables. So what you've got to remember here is your vocabulary. So what the independent and dependent are, is just as a review, is your independent is the one that you can choose whatever you want to. The dependent is the one that is determined by that first variable. So if you think about a standard equation like y equals mx plus b, we pick whatever it is we want for x, we plug it in, we finish the algebra, and that algebra determines what the y value is. So general rule for variables, y depends on x. So since y depends on x, that means x is the independent, the one we can pick whatever we want for, independent, and y is your dependent because it is determined by that x. All right, so identifying these variables, these are not numerical values, these are what does each variable stand for in general. So let's read the two sentences we have. First one, it says a sample of gas has a volume of 5.4 liters at a temperature of 289 Kelvin. That first sentence really doesn't tell us which is which. Second sentence, when the temp is increased, the volume increases. So this second one, the wording of this statement is important. It says when we increased the temperature, that means we were allowed to increase the temperature all by itself, then the volume of the gas went up. So that being allowed to change the temperature first is what makes the temperature the independent variable. So this is the temp in degrees Kelvin. And if you don't know the units, you can just write the words out. The symbol for Kelvin is a capital K. So you could put degree K. The dependent variable, therefore, is the volume of it said it was argon. No idea what that is, but argon gas. And it is in liters. If you don't know the units, just use the whole word. Units for liters is a capital L. All right, part 2, form a table of values for the temp and the volume. So a table means a table of your x and y values. So I've got my x, I've got my y. So a table's like putting the points in two columns. If you want to do rows, you could do rows too. Just make sure they are labeled. All right. So x is the temperature. So if I go back and read that first sentence, a sample of argon gas has a volume of 5.4 liters at a temp of 289 Kelvin. So these two values, there is my x and its corresponding y. So you don't need to put your units in the table, but just make sure they go in the right column. So 5.4 liters being listed first in the sentence does not mean it is an x value. The temperature, 289, is the x, and the 5.4 is the y. Second sentence, volume of the gas is 314. There's our x. The temperature of the gas is 314. The volume is 5.9, so there is our y. So 314 for x and 5.9 for y. So there is our table. All right. Part B, or I guess not part B, part 3A. Calculate the rate of change of the volume in liters per degree Kelvin. Write your answer in decimal. So that means no fractions here. What you've got to remember about your vocab here, rate of change is some sort of ratio. So we have a ratio of volume, which if you go look at your first question, volume is Y. So the ratio of Y in liters, let's go ahead and extend that line, to degree Kelvin, which is X. So we are doing a ratio of Y to X, which is just a fancy name of the slope. So what we're being asked to find here is the slope. All right, formula for slope, difference in your Y values, so Y2 minus Y1 over X2 minus X1. Change in Y over change in X. Rise to run. All right, doesn't matter which set of points is which, because most of you would call the first point the X1, Y1, and the second point X2, Y2. That is what I'm going to do as well. So my Y2 would be 5.9 minus Y1, 5.4 over X2, 314 minus X1, 289. Do a little fancy algebra in our calculator. Make sure you put it in decimal form, not fraction form. It doesn't say how many decimals to give your answer to, so we're going to write down all of them since it's only 3. So 0.032. Another thing to be careful of, word problems, make sure your answers have units on there. If you're unsure, go reread. It says find the rate of change, which means, or calculate the rate of change, which means calculate the slope in liters per degree Kelvin. So there are your units right there. If you don't know the symbols, just copy paste those words in liters per degree Kelvin. I'm going to use the symbols since I know what they are. Liters per degree Kelvin. All right, part B for 3. Write a linear function that relates the volume and temperature in slope-intercept form. So slope-intercept form is y equals mx plus b. However, you've got to, again, read very carefully with your word problems. It doesn't say write the equation of the line in slope-intercept form. It says write a linear function. Now, it's not very clear what to call that function, but because right here it's got that curly f in the name of the function, I'm going to call it f of x. So f of x equals mx plus b. You have to remember to get that y value eliminated and put it in function notation. All right, so from part A, we know our slope. So I already know m. Our slope is 0.032. That sounds right, 0.032. However, I need a point. So in order to get to slope-intercept form, I go choose one of my 2 points, and we're going to pick a point and our slope, and we're going to plug into point slope form, and that will give us, then we can do some algebra on it to get it in the right format. So going back up here to question 2, it does not matter which point you use. I'm going to use the first one because most of you like to use the first one you write down, but technically it does not matter. So I'm going to use the 289, 5.4, and I'm just going to copy it down here so that they're all in the same part. So we're going to use these 2 things, and we're going to plug into point slope form. Point slope form, if you've forgotten, y minus y1 equals m times x minus x1. All right, so y minus my y value, 5.4, equals my slope, 0.032, times the quantity, x minus the x value, 289. All right, so goal is to get this into slope-intercept form. So what I need to do is I need to distribute to clear those parentheses. So it's going to give us y minus 5.4 equals 0.032x. And then we do this little multiplication here. So 0.032 times negative 289. So negative 9.248. And then lastly, we add to get y by itself. It's terrible 4, that's okay. So we have y equals 0.032x, and then combining those two numbers, negative 3.848. Now, a lot of you are going to box this in here. Remember, it says a linear function. So what we need to do is just replace our boring label y with the fancy label f of x. So I'm just going to do that over here. So f of x equals 0.032x, forgot the back number, minus 3.848, minus 3.848. And this is the one we want to box in. It says function, you must have a function label on there. All right. Question 4. In context of this problem, explain what the rate of change represents. So we've got to think back to, well, what is the rate of change? So back up here, 3a, rate of change, that is your slope. So just saying slope is not in context. So you have to explain the slope in terms of the variables being used here. So we're going to start with our slope. We know it's m, and we know it is 0.032. Now the easiest way to explain a slope is to write it in terms of a fraction. When you're explaining in context, don't try to change this decimal to a fraction, just put it over 1. You know slope is the rate of change of y over the rate of change of x, so I need to get my units attached here. So I'm just going to extend my division bar. I want to go get my units for y. And remember back up here, y is the volume of argon gas in liters. So this is the volume of argon gas in liters. I did not make that line long enough. Over my units for x. X is the temperature in degrees Kelvin. So over the temperature in degrees Kelvin. All right, so let's look at a general idea of slope before we go to the specifics. So the easiest way to interpret the slope is you say for every 1 unit increase in x. So we always start with the denominator because the denominator is always 1. So every time x goes up by 1, because we always put it over 1, we expect y, whatever y stands for, it either increases or it's going to decrease. So it's going to depend on whether it's positive or negative. So y is either going to increase, go up, or decrease, go down by whatever m is, so that's your numerator, units for y. So for every time x goes up by 1, y goes up or down by whatever m is in those units for y. So this is your generalized interpretation. So what we want to do is take that and make it specific to this problem. So for every 1 unit increase in x, so if I look at x, it is, the units are degrees Kelvin. So for every 1 degree Kelvin increase in temp, so for every 1 degree Kelvin increase in temp, we expect y. Y is the volume of argon gas. So we expect the volume of argon gas to, our slope was positive, so it's going to increase by 0.032 units of y, which is liters. So for every 1 degree Kelvin increase in temp, we expect the volume of argon gas to increase by 0.032 liters. All right, now that you've watched this video, go download your common assessments, complete it, and make sure you get it uploaded to Canvas before the end of the week.